Today we're going to talk about some more things from first semester. We'll start with Pythagorean theorem. We can only use Pythagorean theorem if we have a right triangle, which means there's a 90-degree angle in the corner. Here's Pythagorean theorem. It is a squared plus b squared equals c squared, where c is the longest side and a and b are the two sides that touch the 90-degree angle. So first example, we're going to find the missing length of this right triangle. The first thing I'm going to do is write Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Now my longest side is c, or the side that's across from the right angle is c, so my c here should be 50. So I'm going to go ahead and write Pythagorean theorem, and I'll make the missing side x. Now I'm going to calculate what those squareds are. So 46 squared, if I do that in my calculator, then I get 2,116. And then 50 squared is 50 times 50, which would be 2,500 or 2,500. So now I've plugged in everything into Pythagorean theorem. Now I need to solve for x. The first thing I have to do is subtract away the 2,116 because it's being added. So that'll take that away, and I'm left with x squared, we'll bring that down, and 2,500 minus 2,116 would give me 384. To get rid of a squared, I take the square root of both sides. So that will take away that little 2, that exponent. See, the square root of 384, I can do that in my calculator by doing second, x squared, 384, and I get 19.595, so I'm going to round that up and say that x is about 19.6. That means my missing side is 19.6 units long. Next, we're going to use the converse, which just means we plug in 3 side lengths into Pythagorean theorem. The longest side should be c, and we see, do the sides equal each other? If they do, then it's a right triangle. If they do not, then it's not. So on this first one, the longest side is 17. That's going to be my c. So I'm going to say, okay, does 8 squared plus 15 squared equal 17 squared? And I'll put a question mark there because we don't know yet. Well, I know 8 squared is 64. I know 15 squared. I could do that in my calculator if I'm not sure. 15 times 15 is 225. And 17 squared, 17 times 17 is 289. Okay, well, 64 plus 225, if I'm not sure, I can do it in my calculator, but that gives me 289. So that means that I'm actually left with, and I'm running out of room here, I'm left with 289 is equal to 289, so we say, yes, it is a right triangle. Next one, my longest side is 6. That's going to be my c. A squared plus b squared equals c squared, so 4 squared plus 5 squared. We want to know if that's equal to 6 squared, so I'll put a question mark. We don't know yet. 4 squared, 4 times 4 is 16. 5 times 5 is 25, and 6 times 6 is 36. Now we'll go ahead and add up this left-hand side. 16 plus 25 would give me 41. And we bring down the 36. Well, 41 is obviously not equal to 36. And so we say, no, it is not a right triangle. Moving on, we're going to find the distance between 2 points. So A and B. The first thing we do is draw a line between those 2 points. And then we go ahead and make a right triangle out of it. Mine's a little bit messy. Now we're going to count the side lengths of the 2 legs. So the 2 blue sides. Well, that first blue side is 2 long, and the other one, I count the squares from one corner to the other, 1, 2, 3, 4, so it's 4 long. Now we're going to use Pythagorean theorem. This side is c because it's across from the right angle, so I'm going to set that up. A squared plus b squared equals c squared. Now let's plug that in. 2 squared plus 4 squared equals c squared, or you could put x squared, doesn't matter. 2 squared is 4. 4 squared is 16, and let's see, 4 plus 16 is 20, so 20 now is equal to c squared. Now we take the square root of both sides because I need to get rid of this little 2. So that'll cancel out the 2. And in my calculator, I would do the square root of 20. So I do second x squared and then type in 20, and I get that C is about 4.5 if I round. You can type that in on your own and check my work. That seems right because that's longer than 4 and 2, so it sounds like I did it correctly. Next, we'll talk about angles of a triangle. There are 3 angles in a triangle, obviously. Those 3 angles should add up to be 180 degrees. So for this first example, we're going to find the value of x and the measure of each interior angle. So I have 3x in that top corner, 5x minus 6 in the bottom right, and then this square in the corner means that this one is 90 degrees. Now I'm going to write an equation and set it equal to 180. So I add up all 3 angles and set it equal to 180. Here's my equation. Now I need to solve that for x. So first thing I'm going to do is combine like terms. So let's see, 90 is a like term to negative 6 because they're both regular numbers. And then positive 3x and positive 5x are like terms. 80 cannot be combined. It's on the other side of the equal sign. So when I combine those, I get 84 plus 8x is equal to 180. Now let's solve that equation. The first thing I should do is subtract 84 because I have to get rid of my addition or subtraction first. That's positive and it's out in front. So I'm going to subtract it. So I went ahead and subtracted 84 from both sides, and then that'll cancel out the 84 on the left-hand side. So all I have left is the 8x, and I brought that down. 8x is equal to 96. We have to divide by 8 on both sides because that's the opposite of multiplication. In my calculator, I could do 96 divided by 8 if I wasn't sure what that is, and I end up getting 12. And so I'm going to write out here to the side that x is equal to 12. Okay, but we're not done. It asks us to find the value of x and the measure of each interior angle. So now we have to take x equals 12 and plug it back in. Well, we already know that this guy is 90 degrees, so that one is done. But let's do the one in the top corner. I have 3x, so instead of writing x, I'll put a 12. So it's going to be 3 times 12, and I know that 3 times 12 is 36. So in the top corner of this triangle, I get 36 degrees. Next angle, or last angle here, is 5x minus 6. So I'm going to plug in 12 for x. 5 times 12 minus 6. 5 times 12 is 60. So it's really just 60 minus 6, which is 54 degrees. So those are my 3 angles, and I got x equals 12. Now I'm done. Next thing we're going to talk about is parallel lines and the angles that they make. Okay, if I have 2 angles that are right next to each other, like these 2 over here, 1 and 2, then those 2 angles add up to 180 degrees. A small angle plus a large angle equals 180. All the small angles are going to be equal to each other if we have parallel lines, and all the large angles are going to be equal to each other if we have parallel lines. That's what these little notations right here mean. So let's go ahead and do this example. We're going to find all the missing angle measures. I am given that one of the big angles is 106 degrees, and I know that these are parallel because of these little markings right here. Okay, so if the big angle is 106 degrees, then all the other big angles are 106 degrees. So I'm going to go ahead and label that. So 4, and then all the other ones. So 6, 10, 4, 2, and 7 are all big angles. They're all going to be equal to 106 degrees. If I want to figure out what the small angle is going to be, I do 180 minus that big angle. 180 minus 106 degrees would get me, let's see, 74 degrees. That means that's all the small angles. So we're going to go ahead back and label that. So 11 should be 74 degrees. So should 5. So should 5, 9, 3, 1, and 8. And I ran out of room there, so I drew some arrows there. But all the small angles are going to be 74 degrees. 106 plus 74 is 180. Last thing we're going to do on this page is solve equations. The first thing I should do is simplify if I have an equation, check for distribution or combining like terms. Second thing I'll do is isolate. If I have variables on both sides, I have to add or subtract to move them over to the same side. And last thing I do is solve. I do order of operations backwards. I undo my addition and subtraction first, and then multiplication and division. So for this first one, I'll draw my balancing line. First thing I should do is subtract 10. When I subtract 10, that cancels out the 10 on the left, and I'm left with negative 7x is equal to 28. Now we're going to divide by negative 7 because it's being multiplied, and I want to get x by itself. That cancels out, and 28 divided by negative 7 would give me negative 4. So that's my final answer. Now we'll move on to the one that has distribution. That's the first thing I do is distribute. So 3 times x is 3x. 3 times 4 is 12. So this is really 3x plus 12 equals 18. Now I'm going to draw my balancing line and subtract 12 from both sides because I have to undo my addition first. When I do that, the plus 12 cancels out, and I bring down my 3x. 3x is equal to 6. Now I divide by 3. That cancels out the multiplication, and my final answer is x is equal to 2. Bottom left, again, first thing we have to do is simplify. So the first thing I do here is combine like terms. I see that I have 3x and negative 2x, taking the sign in front. Positive 4 doesn't have any like terms on the left-hand side, so he's by himself because 6 is on the other side of the equation. So let's combine those like terms. 3x minus 2x is x. Bring down the plus 4. Now I'll solve that equation, subtract 4 from both sides. That'll cancel that out. And I'm left with x is equal to 2. Last equation here, I don't see anything to distribute. I don't see any combining like terms. Looking at each side separately, so I'm just going to draw my balancing line and move to isolating. I have to add or subtract to get my variables on the same side. So I'm going to subtract 7x because it's positive. I have to do the opposite. So minus 7x that takes away the 7x from the right-hand side, and I'm going to figure out my left-hand side. 3x minus 7x would be negative 4x. Bring down the plus 7. And on the right-hand side, I still have negative 13 left. There was a minus sign in front of it. Take it with it. Now I have to get rid of that plus 7. So I minus 7. That plus 7 and the minus 7 cancels out. So I bring down what I have. Negative 4x now is equal to negative 20, negative 13. If I'm in debt $13, I lose 7 more, and now I'm in debt $20. And then I divide by negative 4. Negative 20 divided by negative 4 is a positive 5. So x is equal to positive 5. Last thing we're going to do is transformations on the last page. Whenever we do a transformation, the first thing we do is graph the original shape if it's not already graphed for us, and then graph the transformation. So here's my original shape. I'm going to go ahead and graph that. So here's my original shape. I should label my points. This is point A, this is point B, and this is point C. Now, for my transformation, I'm asked to do a dilation by 1/2, which means I multiply all of my points by 1/2. So really, I'm just taking all of these numbers and dividing them in half. So let's see, A prime would be 1, 1. B prime would be 3, 2. and C prime would have to be 2, 4. Now we're going to graph our new points and then draw our new figure. I'll do this one in black. So you'll notice that my shape is about now half the size, but it looks very similar. It's just a smaller version of what I already had. This one's overlapping a little bit, so I won't label my points, but I would label them A prime, B prime, and C prime. Next problem, we start by doing the same thing. We're going to go ahead and graph our points. I've graphed my points, now I need to label them. This one was A, this one was B, and this one was C. Our new transformation is a translation, it says, and it's x plus 1, y minus 6, which means I go right 1 and down 6. So I'm going to take each point and move it right 1 and down 6. So A ends up right about there, B should be right there, and then C, go right 1, down 6. So this time, my shape didn't change at all, it just did a slide. So I'll connect those dots and make my new shape. So there we go, we went right 1 and down 6, which with each point, there's my new shape.